Okay, now we're going to get into some of the deviations from what we were talking about in the last lesson. So starting with ions. So ions occur when you lose or gain electrons. So we'll talk about what that means. And you'll know you've got this when you can tell me how many electrons a particular ion has, or based on knowing how many electrons something has, you'll be able to tell me the charge. So I want you to look this over. If you need to, pause the video for a little while. So just to kind of give you an idea of what these diagrams are showing you, we've got our neutral atom of lithium here. All right, and we're comparing it to ions. All right, and then here we have neutral fluorine, and we're comparing it to an ion of fluorine. Here we have neutral magnesium, and we're comparing it to an ion of magnesium. So look these over. What do you see changing between the neutral version of the atom and the ion? So some stuff you might be noticing. The number of electrons is different. All right, if you're looking really, really closely, you also might be noticing that there's this extra number on the symbol. All right, so these are some differences when dealing with ions. All right, when you write out the symbol, there's going to be an extra number on it. And you can see that the number of electrons are changing. Everything else, the number of neutrons, the number of protons, those are all staying the same. So what makes an atom an ion? What are some, based on what you saw, what are some of the things that happen? Hopefully you're saying things like a different number of electrons. All right, that positive or negative number on the symbol is a charge on the symbol. All right, so that's the whole F minus or O2 minus, that sort of stuff. But also you can write this as O minus 2, same thing. You may see both ways of writing it. So, real quick, remind me, what are the charges on the different subatomic particles? Your protons, your electrons, and your neutrons. Hopefully you said +1, -1, and 0. So, when an atom is neutral, this is what we were talking about in the last lesson, how does the number of protons relate to the number of electrons? So if an atom is neutral, the number of protons equals the number of electrons. All right, which means that for us to get those charges, we have to have unequal numbers. So this comes from when an element is trying to get into a reaction. Sometimes it reacts better if it has given up some of its electrons or it's taken on some electrons. And we call those ions. So think about it. What happens if your protons and your electrons are not equal? All right, so think neutral. All right, say neutral oxygen, for example, has 8 protons and 8 electrons. All right, but an ion of oxygen actually gains 2 electrons, so it's going to still have its 8 protons, but it's going to have 10 electrons. So what's going to happen to that atom there, right? It's going to have an overall charge of -2. Another example of this would be, say, lithium. Lithium has 3 protons and 3 electrons, all right? But lithium, when it forms an ion, it tends to give away one of its electrons. It loses one of them. So now we have 3 protons, but only 2 electrons. Right? That results in an overall charge of +1. So just so you know what the examples were here, lithium and oxygen. So some vocabulary to become familiar with is a cation is a positively charged ion. I love cats, so I love using them to remember things. So I remember this, cats are positive. And then that means if I see the term anion, then I just remember that doesn't have anything to do with cats or things that have paws. So that means my anions are negatively charged. So let's think about what's going on here. When we form a cation, we get that positively charged ion. So let's say we're dealing with aluminum. All right, so aluminum has 13 protons and 13 electrons when it's neutral. What do we need to do to the aluminum to get that to have an overall positive charge? If you said something about changing the number of protons, this is the one time you get to make that mistake. Because remember, protons never, ever, 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 ever change. All right? So the only way we can form ions is by changing our number of electrons. So if we want overall positive, that means we need to remove some electrons. And actually, aluminum gives away 3 of its electrons when it forms an ion. So then you end up having 13 positive protons and 10 negative electrons for an overall charge of +3. All right, so a negatively charged ion, all right, so let's say like fluorine. Fluorine forms a negative ion. It has 9 positive protons and 9 negative electrons when it's neutral. Now, how do we make a negative ion? All right, we can only change the number of electrons we have, so we need to add electrons. And fluorine, when it forms ions, likes to take on one more extra one, so it becomes 9 positive protons and 10 negative electrons for an overall charge of -1. So see if you can fill in the blanks here. If you lose an electron, all right, so if we give away a negative charge, the ion is positive. All right, and cats have paws, so that's a cation. Which means if you gain an electron, we have extra negatives. The ion is negative, and we call that an anion. All right, so we talked about these rules for neutral atoms. You'll notice that for ions, the rules are almost identical. The only difference is that we have to use our ion charge to figure out our electrons. All right, so if we take our number of protons and we subtract our number of electrons, that's how we'll get our ion charge. So sometimes you may actually need to use it this way. You're going to have your electrons equal your protons minus your ion charge. All right? So I'll solve one of these, Cu2 plus. All right, so we've got a atomic number of 29 and a mass of 64. All right, so that means our protons are going to be 29. Our neutrons are going to be 64 minus 29. Starting with the stuff we're familiar with. So 64 minus 29 is 35. And now our electrons. We want an overall charge of 2 plus. All right? So we're going to take that 29 and we're going to subtract positive 2. Or you can just think about it. Okay, we need to end up losing 2 electrons. So there's going to be 27 electrons. All right, you try oxygen. See what you get. If you need some help as far as knowing the numbers off the periodic table, oxygen has an atomic number of 8 and a mass of 16. So protons are going to be 8 because that matches the atomic number. 16 minus 8 is equal to 8 for neutrons. Our electrons, we want a -2 charge. All right? So you can think of it as, well, we're going to have an overall negative charge, which means we need some extra electrons. Or you can think of it as 8 minus -2 equals 10. All right? We've kind of already done fluorine, so I'm just going to move on to iron. So iron has an atomic number of 26 and a mass of 56. I apologize for my cat crying in the background. So protons are going to be 26. Neutrons are going to be 56 minus 26, which equals 30. And then to end up being positive 3, right, we have to lose 3 electrons, or it's going to be 26 minus positive 3. So there's going to be 23 electrons.